Right. Okay. So yes, it is. It's Friday, end of week 2, and yep. Today we'll talk environments and scoping rules. These are kind of a little bit more like nitty-gritty details of R. Um, Probably if you have good programming habits, um, these kinds of things shouldn't, the stuff we cover in today's lecture probably shouldn't um, like drastically affect your programming, in that these are, I guess, a lot of this can be summarized as if you pick up someone else's code and it's not behaving the way it is, perhaps it could be caused by some of these issues. And there's and R uses certain scoping rules and handles its variables in environments. And basically the good coding practice is just kind of do things as you're supposed to, and these kinds of rules don't kick in. But R is also it's intended to just kind of be a little bit loose in its rules. And so if it doesn't complain much, and if it gets code, it's going to do its best to just execute the code that it's been given. And so there's pros and cons to it. And so today's lecture covers a kind of a lot of the rules regarding what it does. So that's what we'll take a look at today. Okay. I've got a lot of diagrams, and all of those illustrations came from Hadley Wickham's book, Advanced R, which I believe I've linked in the syllabus, and you can read his book for free at his website, at least the online version of his textbook. Okay, so you already kind of have assigned objects and written functions, and you kind of have an understanding of the kind of the global environment and the workspace. Okay, and so right now, kind of all of the objects are created and stored, while you're doing an R session, are going to go in the workspace or your global environment. And basically, when you are in R Studio, pretty much this environment, this global environment, this is where you're going to be working, and this is where most of your objects appear. Okay. When you create a function and you execute the function, okay, that creates what's called a local environment. Okay. And so all of the objects, all of the kind of the values and variables that get created inside a function, those are accessible only inside the function, and those things don't appear inside the global environment. Okay? And whatever exists inside a local environment will take precedence over objects in the global environment, right? And so, that is, in particular, a global object will be masked by a local object with the same name, okay? And what we're going to do with today's lecture is we're going to kind of formalize all of these things to talk about scopes and environments, which can play a role if you're trying to build a complex program, or could play a factor if things aren't behaving the way you expect them to. Okay. All right. And so just to start off, we have to talk about this idea of binding names to kind of objects that exist in memory. Okay. And so, here's a very simple example. You create this vector 1, 2, 3, and this vector 1, 2, 3 exists inside the computer's kind of memory where you're able to access it. And the way we're going to access it is by using the name X. Okay. And so we bind the name X. Okay. This assignment operator binds the name X to the vector, or this object 1, 2, 3. Okay. And so there's two parts. It creates the vector in the computer's memory, and it binds the object to the name X. All right. If you ever get into like computer sciencey type stuff, you might attempt to write a program in assembly or something, and that's all about kind of creating objects and putting them directly into kind of these memory addresses, and you kind of reference the objects directly there. Our language here does does a bunch of this stuff for us, and we don't have to worry about all of those things. Okay. And so the name, kind of points to the object created in memory. Okay. So here, look at this. I've got 1, 2, 3, and I assign it to X. So X, the name X is there. And then I take X and I bind it to Y. And then I also create 1, 2, 3, and assign it to Z. Okay. So what's the difference between Y and Z? Okay. Well, both of those things have the name. Both have Y. The name Y is associated with an object with the values 1, 2, 3. And the name Z is associated with an object with the values 1, 2, 3. Except Y is pointing to the same object as X, and Z is pointing to an entirely new object. Okay, so it's like you have this one object up here that has 1, 2, 3, and both the names Y and X point to the same object up here. Okay, over here you have another object, coincidentally also with the values 1, 2, 3, but the name Z is associated with it. Okay, so you have two instances of 1, 2, 3. Y and X point to the same thing. Z points to the other one. Okay. In R, however, so here I've created this object 1, 2, 3, and I have Y point, and I give it the name X. I say the name Y points to the same object as X. Okay. And then I say, you know what, I want to change the third element in Y to the value 4. Okay. And then I ask, well, what's X? All right. And so, if this were a different language, if this were Python, doing something like this, X, the value in X would actually change to 4. Okay. But in R, it doesn't. X remains 1, 2, 3. And if I were to ask what Y is, it would show 1, 2, 4. Okay. Y would be 1, 2, 4. X would be 1, 2, 3. And inside, what's happening internally in R is there's this behavior called copy on modify. When R says, oh, you know what? You're modifying this thing. What it does is it's going to create a copy. Okay. It creates a copy of this thing. It changes this third value to a 4, and then it associates the name Y to it. Okay. Or I guess it creates a copy where Y is associated to it, and then it changes that value to 4. Right. So these are again real like nitty gritty things of like what's happening inside R, but this also explains kind of the behaviors of R. And if you work in other languages, say languages with reference semantics or things like that, then these kinds of actions would be different. Okay, so in R, X will remain 1, 2, 3. Changing the third value in Y to 4 creates a copy, and Y will have the values 1, 2, 4. Right. All right. Let me go ahead and give you your first quiz answer for today. First quiz answer is B. B as in bear or ball. B is the first quiz answer. All right. So far, so good. Okay. And so let's talk about scope. Okay. So when we do assignment, we bind a name to a value, and then scoping is kind of the reverse process where you try to find the value associated with a name. Okay. And so, if we do this, Y is bound to the value 1 in the global environment. If we call for Y, R is going to search and it's going to say, oh, here's Y. Y has the value 1. Okay. Here, I'm creating a function G. G creates its own local environment, right? Okay. So, and inside the local environment, I'm going to take the value 2 and associate it with the name Y. Okay, so if I run, what is G of 3, right? G is a function of X. So X is going to take on the value 3. It's going to come in here. And what is G of 3 going to return? 4 or 5? Okay. A couple people put in the chat it's going to return 5. And indeed, you are correct. It's going to, X is going to take on the value 3. and it's going to say, okay, y, and it's going to search inside the local environment, and it's going to find the value 2 in the local environment, and it's going to combine 3 and 2, and it's going to return 5. Okay, so it finds y in the current environment, and it returns 5. Okay, if R can't find the value inside its own kind of local environment, it's going to search the higher scope. Okay, and that's known as lexical scoping. Okay, if R can't find the variable in the function scope, that's local scope, it's going to search the higher one. Okay, and so it's generally, again, generally it is bad to write a function where you are referencing objects that have not been defined inside the function, right? So whenever you call a function and you have a function of x, you shouldn't be calling for variables y if y is not created inside the function, because this is going to put you in a situation where R has to search for y outside of its own local environment, right? And so again, this would be poor technique. You know, other languages would error out on this. It would say, hey, you can't do this. You're calling for y. Y is not defined inside here. You're not allowed to do that. R, on the other hand, kind of has a different design philosophy and just says, yeah, you know what? Let's not worry about defining all of these things. Let's not force everybody to, you know, we're not computer scientists. We just want to analyze a little bit of stats and data and stuff. And so, you know, if the function's written a little bit poorly, just do your best, okay? But what that means is R then has to have kind of rules for handling these situations that haven't been well defined. So what it's going to do is it's going to say, all right, well, X takes in 3, right? So we're going to call f of 3. X takes in 3, and then it says Y. I can't find, Y is not inside of here. So it's going to go up, and it's going to find 1, and it's going to return the value 4, right? All right, we have a question. It says, if the function requires X and Y as input, when defined, right? So if we write the function is x comma y and it requires 2 arguments, then yes, if we try to execute it like this, it would return an error because the value y, the argument y was not provided, and you don't have a default value. Okay, but so again, that would be the proper way, is you would say you need to provide an x, you need to provide a y, and then you won't have a situation where you don't know what y is down here. But here we've got, it's a function of x, and then it's calling for y. Y is not found in here. So we rely on R's lexical scoping rule, and it's going to search for 1 up here. Okay, and this is going to return the value 4. Okay, does R have higher order function since it will automatically find values? I'm sorry, what do you mean by higher order function? Does R have higher order function?
It's like function inside a function, call itself or call.
Yeah. So I'll show that. We'll have functions inside functions and stuff like that. Okay. All right. Is that all right? Just the quick difference between this and this, and basically, if you avoid situations like this, the rest of today's lecture you don't have to worry too much about. Okay, because we're going to get into all of these weird wonky rules, right? And we have all of these rules because R is meant to be kind of this language that says, well, if you wrote some bad code, you know, R is going to try to figure out the best, right? And whereas other languages would just say like, error, okay? And that's the design philosophy, which just means R needs to have rules to kind of fill in the blanks when it gets a little bit of bad code, okay? All right, so let me just read this bunch of wall of text here, okay? All right, so variables defined within a scope only exist inside that scope and only for the duration of the scope, all right? If variables with the same name exist outside of the scope, those are separate and they don't interact with each other, nor are they overwritten, okay? A function is its own separate environment, and really the only way it communicates to the outside world is via the arguments going in and the object being returned. So for example, if you execute this command, rm list equals ls, which is delete everything in the environment, okay? And you know, you should never really do that. What it would do is it would just delete all the objects that have been defined inside the function, okay? It would not actually affect anything in the global environment, okay? The only exception is the super assignment operator, okay, which is kind of this double-headed arrow. And that's going to search the higher scope and the global environment. This is a dangerous operator. It exists, but it's a dangerous operator and you should not use it, okay? So, and I'll show you a few examples, but if you're stuck in a situation and you feel like, oh, you know what? I bet I can solve my problem with super assignment. The answer is no, don't do it, okay? Certainly almost there's gonna be another way that you can solve the problem without using super assignment, okay? Don't use super assignment if you can avoid it. Okay, so here's an example where I put a function inside of a function. All right, so inside the global environment, I have X, Y, and Z all take on the value 1, okay? And I have the function f, all right? Inside f, I assign the value 2 to y. And inside f, I create another function called g. Inside g, I assign the value 3 to z. And I say, g, you know what? You need to, g actually doesn't even take in any arguments. And g just says return x plus y plus z. Okay. And that's defined inside of g. And then, but when you run f, all f does is it returns whatever g returns. Okay, all right, so quiz. If we run f, what's it gonna return? It's gonna return the value 6, okay? Exactly. And then if you run f, what are the values of x, y, and z in the global environment? Well, they're gonna remain unchanged. They're all gonna stay 1, okay? So when you run f, it's gonna be 6 because it looks for x, it doesn't find it here, it doesn't find it here, it keeps searching higher scope, and it finds x as 1. When it looks for y, it's going to say, all right, let's search for y. Y is not inside the local scope for g. It's going to find the value 2 for y inside the scope for f. And when it searches for z, it's going to find z inside the scope for g. And so it's going to be 1 plus 2 plus 3, and it gives 6, right? And then x, y, z in the global environment are all unaffected at 1, 1, 1 each. Okay, good. All right, well, so we'll get some more weird situations here, but let's talk about environments. All right, so the way scoping works is R has these structures called environments, okay? And the job of an environment is to bind names with values, okay? And you can think of an environment as kind of a bag of names, all right? And so you have these objects inside memory. So you got false and 1, 2, 3 and A and 2.3 and stuff like that. And here we're binding the names to these things, okay? And this is inside new environment. Okay, we got a question. It says, if we were to print Z inside of F, it would still be 1. Let's see. Yeah, if you called print Z, yeah, it would take on the value 1. Yeah, exactly. Okay, so this is an environment. It kind of looks like you've got list notation, but it's not a list, right? You've got this $ notation to kind of indicate like the name you're talking about. But this is all exists inside environment E, and it's different from a list, okay? It looks a lot like a list, right? So environments themselves are objects, okay? The syntax to work with an environment is similar to lists in that you can use the double bracket or the $ operator to get set values, right? So you say type of, for E, it's an environment. E $C is 2.3, E double bracket, the name D is 1, 2, 3, okay? So as we have here. Okay, but the key difference is that environments are not ordered, right? So you cannot say, what was the first object in E? Okay, that's going to give an error, right? You can't, when you subset an argument, you can't say, I want the first object or second object or third object. You're basically like looking inside of a bag, okay? If you open up your bag or your purse and you say, okay, what's the fourth object in the purse? You're gonna be like, well, I never really numbered these things, okay? So you can't reference things inside a bag by calling, the first, second, or third object. You can list off the objects inside an environment by doing ls, okay? And if you just call ls on blank, it will do it for the global environment. Yeah, the first quiz answer was B, yes. Okay, and then you can also ask for kind of the structure, the ls.str, and this will kind of just list off a little bit more detail of each of the objects inside that environment. All right, so unlike lists though, okay, in a list, normally if you assign null to an object or something in the list, it would just kill it, okay? Here, it still exists. It still exists. D is now just the null object, okay? Versus in a list, when you assign null to something, it would just kill that list item. All right. So if you want to actually remove an object from an environment, you have to call rm, okay? And if you don't supply this environment argument over here, it would just do it in the global environment. But here we're going to say remove object D from the environment. And then when we say, okay, what's inside of E, we've removed it. Okay. Environments have what we call parent environments. Okay, so every environment has a parent, and in these diagrams we have these little circles that kind of point to the parent. And this is how R implements lexical scoping, right? So first it's going to search its local environment to look for a name, okay? And if it doesn't find the object in the local environment, it's going to search its parent environment, okay? And then if it doesn't find the parent environment, it goes to the higher environment, so on and so forth. And then it keeps going until it reaches the empty environment. The empty environment is the kind of the ancestor of all environments, and it has no parent, okay? All right, and so I guess we have to talk about all of the different environments. So the global environment is the one you're working in, okay? And the parent of the global environment, okay, it feels a little strange, is going to be the last package that you've called, right? So if you say like, I want library ggplot2 or something, okay, that's going to be the parent of the global environment. Every time you load a library dplyr or something, that's going to become the parent of your global environment, whichever one you've done last. And then, and so anyway, you've got kind of all of these parents, and then above that you have the base environment, okay? That's the last kind of environment you have, and the parent of the base environment, which is base environment, is where kind of all of the base functions exist, things like C and you know, matrix and stuff like that, okay? Things to create matrices, things to combine things. That's the base environment. And then the base environment has one environment, and that's the empty environment, and that's the only one that's not a parent, okay? And if you call environment, that's going to be your current environment. So kind of all of the environments that get loaded is going to show up in what we call the search path, okay? The search path, because again, the reason why it's called the search path is because it's going to search the global environment first, right? You give it, so when so in R here, if I say, let's create, let's just do 1 through 5, okay? X is 1 through 5. So X exists inside the global environment, right? But I can do something like, I want the mean of X, okay? And it finds the mean. I want the standard deviation of X, okay? Now, I don't have a function mean defined here. I don't have a function standard deviation defined here, all right? So what is R doing when I call for the mean or when I call for the standard deviation? What it's doing is it's going to go up the search path, okay? It's going to search package, well, in this case, knitter. It's going to search package stats, package graphics, package graphic devices, utilities, data sets, methods, auto loads, until it reaches package base, okay? And you can find, if you delete, if you just call SD, it's going to say, oh, you know what, this exists in namespace stats, okay? If you ask for mean, it exists in base, okay? So mean is a base function, whereas standard deviation is a value that the function exists in package stats. Okay, and that shows up in the search path. All right. So the illustration is you've got the environment, all of these packages. One of them is going to be, package stats. Package stats includes things like LM and stuff. So, when you call I want to create a linear model object, okay, that exists inside the environment stats, the namespace stats, okay, and until it gets to the base environment, and the base environment's parent is the empty environment. So it just kind of keeps searching all of these. It searches for, when you say, I want to take the standard deviation of something, it searches here, doesn't find it, searches here, whatever, finds package stats and says, standard deviation function exists there. Okay. And then when you load a new package in the library, right? So I've got package A, B, and C. If I say, let's load up a new package, library D, okay, then that's going to show up in between the most recent package and the global environment. Okay, so the new one gets loaded here, right? And then the parent of the global environment now becomes whatever this is. So every time you load packages, the order, matters. So if you have one package and it has, some function named F, and another package and it also has a function named F, whichever one you loaded last is the one that's it's going to reference that one, because that one's kind of the most immediate parent. If you want to reference a specific thing, right? So let's say, here let's say I'm going to create a function stats, okay? Or not stats, standard deviation, right? This is a terrible thing, right? And it's just going to say standard deviation. All right. So the function is just going to actually not even print. Let's just return. It's just going to return this, right? So if I call SD, it's going to just return a string here. Okay. Let's give it a function. Okay. So if I call standard deviation here, and if I have X here, and if I do standard deviation of X, it's going to return this. And I'm like, oh, I don't want that, right? So if I want the actual regular standard deviation, because the scoping rule says anytime I call SD, it's going to just search the immediate local environment, which is the global environment. And this is not the function I want. I can reference the one I actually want by doing stats : SD of X, and then this will work. You know what? I can see you guys squinting, so let me make my screen bigger for you guys. Oh dear, now I can't. Right, there we go. Okay, so what I've done is I've defined a function SD inside my global environment. This is a terrible function, and all it does is it prints out standard deviation onto the screen. And any time I call SD of X, it keeps doing that, right? And this is very annoying. I actually want to calculate the standard deviation. And so in order to kind of reference the real one, I can ask for stats in here, okay? I'm just going to remove it so we don't run into this problem anymore, okay? And now it works. Okay, do you need to run the library code if you specify with the double bracket? If you want to use dplyr without this, let's see. So yeah, the terrible SD lives in the global environment. Let's see. If you don't, yeah, I think, let's see. I think you can just call things. Yeah. So yeah, you can call it without using library. Yeah, you can just kind of reference the things without loading it in library. Okay. So anyway, the environments, I got to work faster here. The environments that you work with are often consequences of kind of creating functions. And so whenever you make a function, you're going to have a few environments associated with it. You have the enclosing environment, the binding environment, the execution environment, and the calling environment, okay? The enclosing environment is the environment where the function was created, all right? Every function has one and only one enclosing environment, okay? As for the other types, there can either be 0, 1, or many environments, right? And so the binding environment, when you give the function a name with the assignment operator, that's where the name exists is the binding environment. When you call the function, that creates the execution environment. This is the temporary function or temporary environment that kind of stores all of the variables. And every execution environment is associated with a calling environment, which tells you where the function was called. Okay, so this is a bunch of like gibberish right now. But I'll try to give you some examples that kind of clarify how this works, okay? Let me go ahead and give you your second quiz answer. Second quiz answer is A as an apple. A as an apple is your second quiz answer. All right, so when a function is created, it gains a reference to the environment where it was made. This is the enclosing environment, and it's used for lexical scoping, all right? When you name a function, the environment where the name exists is the binding environment, right? And so most of the time when you're making functions, both the enclosing environment and the binding environment are the same. So here is just a simple example. In the global environment, I bind the value 1 to y. Okay, so the name y is associated with the value 1. And inside the global environment, I create a function f. And f takes inputs as an argument to the value x, and it's going to return the value x plus y. Okay, so we say, where's the environment, the enclosing environment of f? It's the global environment. F is inside, it was created in the global environment, so that's the enclosing environment. The name f exists in the global environment, so that's also the binding environment. In the search path, we saw that the parent environment of a package varies based on what other packages have been loaded, right? And so if, let's say you loaded a whole bunch of packages, right? And that's going to kind of change. Like if you load packages A, B, C in that order, and somebody else loads packages C, B, A in that order, then you know, for one person, the parent of B is going to be package C, and then for the other person, the parent of package of, you know, environment B is going to be A, right? Because it depends on the order that you load. And so that could create problems if there's like certain functions that have the same name. And so to kind of avoid that, R uses what's called a namespace, okay? And so if you look at the definition of the standard deviation, what it does is it first finds the variance, and then it takes the square root, okay? That's effectively how R calculates the standard deviation, is it calls the function variance, you know, after it does some other stuff, okay? It calls the function for variance, and then it takes the square root, okay? And so what if somebody defines another function called variance, right? Like you create one in the global environment, or you create it in another package or something like that. How can we make sure that this standard deviation function is always going to call the correct variance function and not something else? All right, well, that's handled by the namespace, okay? And so this is when your enclosing environment and binding environment is going to could be different, okay? So 99% of the cases when you're kind of like writing your own code, your enclosing environment and binding environment are going to be the same. But in order to kind of ensure that packages work the same way, regardless of what packages are attached by the user, right? Packages require an internal environment called the namespace, in which the package functions are defined. Okay, so those are going to be your enclosing environment. All right, and so every function in a package is going to be associated with a pair of environments. That is the package environment and the namespace environment. So the namespace is kind of, it's going to be its enclosing environment, and then where the names exist will be the binding environments. Okay, so the enclosing environment is the namespace, and those are all kind of properly defined with where the functions exist, and so it will use the appropriate scoping rules. Again, you really only have to worry about that when you start writing your own packages, okay? Which some of you probably will. Some of you will write your own R packages. And then these things will matter. Okay, so the package environment is the external interface to the package. This is the environment which the R user uses to find a function in the attached package, and its parent is determined by the search path, right? The order in which the packages have been attached. Okay. The double colon operator, which we saw this, can be used to access a function directly from the package environment, regardless of the search path. And so we can call base mean refers to the main function in the base function, whereas mosaic mean refers to the mean function that exists in the mosaic package. Okay. Double colon notation allows you to access objects that may have been masked from other objects by kind of the search path. Right? So normally when you just call mean, it's going to do base, and mosaic mean do the same thing? Well, I mean, sort of, but not really. Okay, so mosaic mean allows for it takes in like some certain notation. It has do this. They both take the mean of things, but mosaic has its own version of mean, and we want the one in aggregating, and it makes these it makes the functions what we call formula aware. So mosaic, you know how like in LM you define like y tilde x and stuff, and you can do stuff like that. Mosaic allows you to take means with kind of that formula notation. Okay. All right. Okay, so the namespace is the internal interface to the package. The package environment controls how we can find the function, and the namespace controls how the function finds its variables. Okay, so the package environment tells us how we find the name standard deviation. Okay, and that goes in the kind of the search path, whereas the namespace is, you know, standard deviation references the function variance. Okay, and it's going to use the namespace to figure that out. Do base and mosaic? Oh no, sorry, that was the same question. Okay. All right. So every time. So anyway, that's all we're going to say about things, and I got to go fast. I got 11 minutes left. Okay. Okay. So whenever we call a function, a new environment is created to host the execution, and the parent is the execution environment. The parent of the execution environment is the enclosing environment of the function. And once the function completes, the environment is thrown away. All right. So here's a simple function. H is a function of x. Okay. Inside H, we associate the value 2 to a, and then we're going to return x plus a, and then we're going to run H on the value 1 and assign it to the value y. All right. So what happens? Okay. We call H with the value 1. Okay. So inside this environment for the function, x gets associated with the value 1. Okay, this just happens as soon as you call H, because x has the name 1. The name of the argument is x, and it takes on the value 1. Okay, so immediately, as soon as you call it, x takes on the value 1. Okay, as the code is running, then we take the value 2 and we bind it to the name a. Okay, and then it's going to return x plus a. It's going to return 3. All right. And so this execution environment here disappears, it goes away, and now the value y is associated with the value 3. Okay, and then so everything that it used to exist where x equals 1 and stuff, that's all gone. The calling environment, okay, when you call a function, it creates an execution environment, right? And so the execution environment has two parent environments, okay? The enclosing environment where the function is created and the calling environment where the function is called, okay? If you created the function in the global environment and you call the function in the global environment, then the enclosing environment and the calling environment are the same, okay? But in some cases, you might call a function from inside another function. And in that case, those environments are different. The enclosing environment is where the function is created, and the calling environment is going to be inside the other function where you've called it, okay? And so the normal scoping rules will use the enclosing environment, okay? So whenever it looks for values that it can't find, it's going to go through the enclosing environment, not the calling environment, okay? There is something called dynamic scoping, and I've got a couple examples at the very end where you can use the calling environment if you need to. All right, so here I've got x and y, 0 and 10 in the global environment, okay? Inside function f, I've got x is 2 and y is 100. Inside of f, I create the function h, okay? Inside of h, x takes on the value 50, x, and then it asks for y, and then we ask for, and what f will do is it's going to return the value h. Okay, so I'll just tell you what's going to happen, okay? So when it executes h, all right, it's going to come in here and it's going to say, all right, h takes, it's going to run h and says, okay, x takes on the value 50, and then it searches for y. It can't find y, and so it's going to look for the enclosing environment of h, okay? H was defined inside of f, and so because it was defined inside of f, it's going to find the enclosing environment of h is inside of f, and so when it looks for y, it's going to find this y here and take on the value 100, and it will return 150. Is that all right? And that's because h was defined inside of f, and so when it couldn't find the value y inside of h, it's going to search its enclosing environment where y takes on the value 100. Okay, over here, I've got g, okay? G, inside g, x is 2, y is 100, and we call for h. Inside of h, x takes on 3, and it returns x plus y, okay? H is defined inside the global environment, okay? So when we call h, okay, if I call h, x is going to take on 3, and so we've got 3, and it's going to search for y, and y is going to come over here, and it's defined inside the global environment, so it's going to find 10, and so when I call h, this is going to return 13. Is that all right with you guys? That h returns 13. Okay, now what happens when I call g? Okay, inside g, x takes on 2, y takes on 100, and then we call h. All right, so when we call h, we come over here, and we basically execute h. Inside h, x takes on the value 3, and then it searches for y. And where's it going to find the y? It's going to find the y in the global environment again, okay? Because the enclosing environment of h is the global environment. And so this is going to take on the value 10, and it's still going to return 13. Okay, so both of these, h is going to take on the value of 13, and g is also going to return 13. Okay, all of the explanations are on these slides. And the reason for this is that as far as g goes, okay, we're calling h inside of g, and when we call h from inside of g and it can't find values, it searches its enclosing environment. H was defined in the global environment, so it's going to look the global environment. It doesn't care about what these values were inside of g. Okay, so h returns 13, g returns 13. Is that good with everybody? Okay, great. Okay, let me give you your last quiz answer for today. Last quiz answer is C. C as in cat. C as in cat. Yeah, if we defined h inside of g, it would return 103. You are correct. If we defined G inside of, if we defined H inside of G, it would return 103. And that's kind of what we have here, okay? Where we defined H inside of this function F. Okay, so here is an example where we have dynamic scoping, okay? So this is not the very end, but so here we have H. H is defined inside the global environment, okay? And normally when you can't find Y inside of the function, it searches its enclosing environment, which would be the global environment, and it would search Y for 10, okay? But inside of H, instead of using the regular scoping rules, we're going to use get, okay? And when you say get, you can say, I want you to search the parent frame, and this is going to search the calling environment, all right? And so when I call H here, okay, when I call H directly, it's going to do X is 3, and it's going to do Y. And here it's going to ask, where did we call Y? Y was called from the global environment. And so search the global environment. I mean, where do we call H? H was called in the global environment. So search the global environment for the value Y, and we're going to get 10. And then it will return 13. So H will return 13. Okay. However, when you call G, with this, it's going to say, okay, inside G, X takes 2, Y takes 100, and then we call H. Inside H, X gets 3, okay? So X is going to take on the value 3 here. And then when we say, okay, well, what is the value Y? It's going to say, well, where was H called from? H was called from inside of G. And inside of G, Y takes on the value 100. And so it's going to return 103, okay? So this one's going to return 13 because the environment where we called it is the global environment, and Y has the value 10 in the global environment. When we call this, the Y inside of H is going to take on the value 100, and it's going to return 103. Okay, so H returns 13, and G returns 103. Is that all right? That's dynamic scoping. Okay, and that allows you to call, use the values inside the environment that called the function rather than the values when it's searching for things from the enclosing environment. Okay, and again, this is like, you shouldn't encounter this too often, because generally when good coding practice is that you shouldn't be in a situation where you don't know what Y is, where it has to do scoping, right? Like the value Y should come into the function. It should be unambiguous. Okay. Okay. Oh, I've got a few slides on super assignment. Okay, but basically, don't use super assignment. Is the summary of all of these slides is don't use super assignment. Okay, it exists. Sometimes you'll read other people's code, and then you'll see this double arrow operator, and you'll be like, "What is that?" Okay, that's super assignment. Okay, and there's nothing super about it other than it goes over your, it goes outside of the scope, right? Okay, so here what's happening here is X, Y, Z take on the values 1 in the global environment. And then what this function will do is it assigns the value 3 to Y, it super assigns it, and then it returns Y, okay? So when you execute F, F returns 3. That's no surprise, okay? But if you ask, well, what are the values X, Y, and Z in the global environment? It changes the value of Y in the global environment, okay? Yeah, default scope is enclosing environment and is non-dynamic. It's where the function is defined, okay? So this is like, you're like, oh, that's cool. I can change things in the global environment from inside a function. It seems cool, but it's not, okay? So this is just where, you know, things can get wonky. Well, this example isn't too bad, right? X, Y, and Z are 1 in the global environment. We're going to super assign 2 to Y, and that's going to change the Y in the global environment to 2. This would change the value Z in the global. Well, it's going to, what it does is first it looks for Z in the environment for F. It's not going to find it. And so it goes to the, ends up in the global environment. So it kind of goes to the higher environment, it looks for the thing, and if it doesn't find it, it goes to the higher environment, okay? So it tries to find Z here, it doesn't find Z here, it comes all the way up here, and Z takes on the value 3. And so in the global environment, we're gonna have 1, 2, and 3 for X, Y, and Z, and then it's gonna return 6. Okay, F returns 6, and in the global environment, we have 1, 2, 3, okay? What if the global doesn't have Z? Then it just creates it, okay? So if it reaches the global environment and that object doesn't exist, it's gonna just create it in the global environment. Yeah, the third answer to the quiz was C, okay. All right, so here, this is where it starts to get weird, okay? X is 1, Y, X, Y, and Z are 1 in the global environment. Here I create Y in the local scope, and then I also change Y in the global environment in the higher scope to 4. Okay, so this is going to become 4. Inside of G, I assign 3 to Z with the super assignment operator. And I know I'm over my time. And then it's going to, so that's going to look for Z here. It doesn't find it. It goes to the global environment and it changes the Z in the global environment to 3. And then it says, all right, return X plus Y plus Z. Okay. It searches for X. It doesn't find it in G. Searches for it inside of F. It doesn't find it. And so it says, okay, X gets the value 1. Then it says, well, what's Y? Okay. And it doesn't find it inside of G, but it's going to find it inside of F. And what is the value of Y inside of F? It's the value 2. Okay, it's going to find this one inside of F. Okay, and then lastly, Z, it's going to find Z inside the global environment 3. So this is going to be 1 plus 2 plus 3. So this is going to return 6, but inside the global environment, it's going to be 1, 4, 3. And we have this. Okay, so normal assignment always defines in the local environment, and super assignment keeps searching until it reaches the global or the first, it searches until it finds its first encounter and it modifies that. And if it doesn't find that, it keeps searching until it finds it in the global environment. And if it doesn't find it there, it creates it. I've got a few more examples, but okay, why don't we, I've got more examples here and you can kind of read through them. All to say, super assignment is dangerous and you shouldn't use it, okay? That's the moral of the story. Super assignment is a dangerous thing. Sometimes you think like, oh, this is the answer that, you know, certainly, almost certainly there's a better way to do it, okay? So I'll let you kind of look at that, but basically avoid super assignment. Super assignment can be dangerous and things like that, so. When could it be useful? There is reference objects, reference class objects. And so in certain cases, you want to create these objects with reference semantics, and then you would use super assignment. And so when we do object-oriented programming, we might see super assignment. But actually, with the advent of R6, even then, you don't need super assignment anymore. So. Okay, but anyway, we'll end here for today. Have a good weekend. There's no class on Monday. It's Martin Luther King Day. So, you know, we want to kind of observe and honor the, you know, Martin Luther King and other civil rights leaders, but, you know, still acknowledge the work that still needs to be done with, you know, racial reconciliation. So, we'll see you guys in class on Wednesday. Okay, so have a good weekend, and we'll see you guys on Wednesday.
Professor, I had a question